All right, well, let's talk about a few more of these manual tests. Here's shell code injection. And this nice simple example. So here you have a PHP script, and it takes an IP address as the input. And there's an HTML page that takes an IP address and passes it as a parameter IP to a PHP script. And here's a script which does the classic flaw. It makes sure you have an IP or it gives you an error. And if you do have an IP, it creates a command line command, ping minus C2 IP, and discard the error messages, which is what this does in Linux. And then it executes that system command. So it takes data that came from the user and it puts it in a command line. This is an extremely common sloppy coding procedure where you don't know how to do what you want in the original language. Like I don't know how to send a ping in PHP. So instead of figuring out how to do that, I create a line of code and pass it to a different language, in this case, Bash. And this is how you always create this kind of problem. When you generate code and then pass it to a different interpreter, you run the risk it'll be misunderstood. And of course it is. So I think this one's all ready to go. SC202. Oh, that's 203. Let me go to 202. There. Oh, all right. That's right. I made various versions of it. So there's the original one. So I can give it an IP address like 1111 and ping. And it does the pings. And you see it's just giving me the ping reply, 64 bytes from the server and another 64 bytes. But if I can do a ping and I can do a semicolon ID after the number, and it will pass that through, do the ping, and this is the response of the ID command. So I now have command injection. I can execute code on the server by putting code in the IP address. And I'm not the administrator. I'm the Apache user, www data, but still I can do things like anything the Apache server can do, like deface the web page. So that's a very common flaw. And again, there's just a few steps here where you have to fix it in various ways. See, there's your code injection vulnerability. And so the first thing is to remove a couple of dangerous characters, but that's not a very strong defense because there are other ways to achieve command injection. And what's better is to do allow listing instead of deny listing, where you only allow good characters, such as only numbers and dots in the IP address, nothing else. That would be a much superior defense than trying to enumerate the bad characters and remove them. So that's code injection. And the next one is SQL injection. So here's a simple SQL injection. First you install a database, and the standard is MariaDB, which is just a clone of MySQL, and then run the typical installation of it. And then you create a user database that contains Charlie Brown and Linus Van Pelt, just a couple of employees in your employees table, and run that thing. And now you have an HTML form where you can search for things and a script. So the form here is just like all the others. It takes an ID and a name and passes it to a PHP script. But the PHP script here takes the data and then it does something. This has got a lot of severe flaws, but this is a very common way to do it. You put secret information in the source code, which is a very common flaw. So it's got the name of the password, the administrator password in the source code, and then it creates a connection and it searches the database with MySQL I query, where it's going to do a line of SQL commands, and it's going to take data that came from the user and put it here, name equals name or ID equals ID. This is the classic SQL injection flaw, and it's just like the bash command injection. You have taken the PHP language and you've used it to create a line of code, which you then pass to a MySQL parser. And that flaw is, of course, the user might know how to put in crafted data that will confuse that parser. So this is 203. So we take a look at 203. That's here. And so if I give it a name like Charlie Brown, it should find that person, and it does. But if I put an apostrophe in it, then it gives me an error in SQL syntax. And this is the fatal error. When there's a syntax error, that means you broke the line of code so it can't be processed. And that should not be possible. There should not be any information that came from the end user that will break the syntax of your line. If there is, that means that after that apostrophe comes commands, and they can eject commands. And so, as you saw in the web application, you can now log in without knowing the password, delete tables, and do all sorts of bad things. So again, that's the flaw. And now there's various, you try to fix it with various ways. Again, very similar. So the first fix is just removing apostrophes. That will stop some SQL injections, but not all of them. And much better is to use proper parameterized queries. This is the modern solution. Instead of having vulnerable code that uses MySQL query and has a line of code that has to be parsed where you have to match the apostrophe here with the apostrophe there around the name, you use this, you use a different way to connect it. You declare a statement here. You prepare a statement where name equals question mark. The question mark is a placeholder for data. Let me make this bigger. And then you bind parameter name into there and execute it. So the name is equal to something, and this is a data object that came from the user that cannot be misunderstood as a code object. There is not an apostrophe at the start of it and another apostrophe at the end of it. It is handled as a data object inserted in a way that can't be misunderstood by a code object. This is the right way to do it. So when you get the parameterized queries working, then you're really preventing SQL injection, and that's this will check to make sure you've really done that. And then there's local file inclusion. This is a very common flaw with PHP. So here, I make the HTML page, and it's going to have 3 possible pages, buy, sell, or help. 3 different pages you might get. And so it's going to pass a variable named page to the script, and the script is going to fetch that page by name that came from the user. So this is a very common situation in PHP where a variable contains the name of a file, and that variable is controlled by the user. And the problem is you can do directory traversal, also called local file inclusion. I can load a page that was not intended. So let me open this one, 204. All right, and so here I could get the buy page, and I see what the contents of the buy page, which is buy low, but I could also point to something else, and I think I could just do /etc/password. Yep, and now I see this password file, which is world readable, but it is not supposed to be handed out by the web server. And that's local file inclusion. I'm able to, or also called directory traversal. I'm able to go somewhere that the developer of this web page did not intend for me to go. And so once again, you've got a couple of different layers of fixes for that. The first one is remove characters like .. And the second one is fix the real path. This is the right solution for this. You use the real path function, which will give you the full path from the root to wherever you are, and then you only allow it if the real path begins with var www.html. This is the right solution. So whatever combination of characters point to somewhere like .. or whatever, you will only serve files that are in this directory. And by the way, I should mention, this is all in this textbook. There's an excellent textbook, Designing Secure Software. This is a great book, and what I'm doing in here is all from this book, essentially. They really have nice discussion of the various flaws and how to fix them, and that's what I base a lot of these projects on. So there's a few more of these manual fixes. Hard-coded secrets. There's one you already saw earlier. This is extremely common, and this especially gets people to put their code on GitHub. If your developers put secrets in the source code, then later on somebody decides to put the source code on GitHub, then later on somebody else decides to make that public, which is how it happens. Then and those might have been different people making each of those decisions without understanding the consequences. An enormous number of people end up leaking secrets on GitHub. So here I take a password and pass it up to a PHP script. And the PHP script goes here. And this is going to look for a password. If the password is Open Sesame, you get in. Otherwise, it's incorrect. All right. And so now you have essentially a login form looking for a password, and it will say welcome, and if it's incorrect, it'll say incorrect. So this is a very rudimentary login system, and it makes a copy of your PHP source code here so you can see it, which is, of course, extra functionality not you put on a real server, but it's here so I can test your source code to see if it works. So now you can test your code automatically to make sure all that works, and then we can do something better. Now, the way it is now, this is a insecure, hard-coded secret. You have the right answer right here in the script. If password equals Open Sesame. Now, this is a common practice, but it's a really bad practice for two reasons. The first reason is, as I say, your source code frequently becomes available for a variety of reasons, and then you're sorry because people can see the password. Another one is, what happens when you need to change the password? You frequently need to change a password, either because you have the old-fashioned rule of changing your password every 90 days, which, by the way, is no longer recommended by the U.S. government and hasn't been for years, but every single company I consult for is still making everybody do that. The memo has not gone out. Or because you have password compromise and you have to change the password. If you're putting your password in your source code everywhere, it's really hard to find it and change it correctly everywhere. The right thing to do is have a central password management system running. And so what you typically do is you use environment variables as one way. So now I define an environment variable called password 205 that's Open Sesame, and I use that in the PHP script. And this is why, as we saw in the web application security platform, this is why the PHP info would be bad because it shows the environment variables. But this is one place you often store secret passwords. And then you got fixed code that does that. So you can upgrade your stuff that far, and this test will see if you've actually done it. And the last one in this series is integer overflow, which is one of the most maddening things about C and all C-derived languages, which people are beginning to finally admit that C is just too dangerous to use, and they're moving to secure languages like Rust. But one of the many traps of using C is the way it handles numbers. So if I define an 8-bit number called length, and then I input the name from somebody, and then I check the length, and if the length is greater than 10, it's too long. The problem is you can put it in with a short name and a longer name. If you put in a short name, it's okay. If you put in a longer name, it tells you it's too long. So that's the operating as intended, and you can connect it to an HTML form and a PHP script, which we'll call it, and that's fine. And put in a longer name, it'll tell you it's too long, so that's fine. But then you can make an overflow. So if you put in a name that's 50 characters long, it will be rejected. Let me bring this up. This is 206. Let's give it a shot. Okay. So this is a web form that uses an underlying C source code. So if I put in short names, they're fine. If I put in a longer name, bang, bang, it's too long, longer than 10. All right, now, if I put in 50 characters, that's also too long. Okay, but if I paste it 5 times into the form, that's 1, Control E will take me to the end, 2, 3, 4, 5. Okay, I submit that. It's still too long, but it's 250 characters long. So if I append hello there to the end of it, Control E takes me to the end, hello there, and send that, now it accepts it because it's 260 characters long, so that wraps around and is interpreted as 5. And how is a developer supposed to know this? This is many problems with C that lead to this. And so that's the integer overflow. And again, you can fix it. And the fix here is modify it so it'll correctly reject them. And I don't think I told you how here, but there's a lot of ways to do it. One is just use a better variable type for that integer that would have a different rollover point. And so those are some manual tests. And I realize from what I'm saying here, I should show you something that's not on this page, but let me find it. I should show you the Rust project. So I'm going to stop this video and then show you that, because that is another way to see this. Let me stop.